Part 3 is concerned with problems 9 through 11. Again, we are going to skip problem 12, but problems 9 through 11. And I'm going to tell you right now that this is probably the most important part. This is something that you need to get down. You need to understand the following terminology: inequality, interval notation, and set builder notation. You need to know how to write in all three of those because it's very important. And really just the bottom line is these three words here, inequality, interval, or terms, inequality, interval notation, and set builder notation, are three different systems for writing the answers to any particular problem that has usually more than one answer. And a lot of problems that we're going to deal with end up having more than one answer. If I were to ask you what is a number above 5, well, there's a lot of answers like 5.1, 60, 1 million. There's a ton of answers to that, infinitely many. And sometimes you're going to have problems where that's the case, is where you have infinitely many, but specific ones. You know, you can't, if I said any number greater than 5, well, 4 is not part of that solution. So really, we got to be careful about how we choose our numbers, and we got to make sure that we're saying it in the right way. So again, this is easily the most important thing that we're going to talk about in this lecture. So the first thing I want to talk about is symbols and what they mean, and you're going to have to know these. Less than or equals to, greater than or equals to, greater. This one represents such that, and I'll just put such that. And this is really a glorified set of parentheses, but when we use this one here, typically we use it with set builder notation, which is down at the bottom here of this page, set builder notation. And obviously I think you've seen greater than, less than, and all those ones, but the such that and the set builder notation might look a little new to you today. So first thing we want to do is we're actually going to take this problem right here. X is greater than 1. And we're going to, at first I want to map it on a number line, but we're going to write that answer as an inequality in interval notation and set builder notation. But I think it's helpful to have a number line out on that first. So if you take a look, I've set one up here as 0, and this goes 1, 2, 3, 4, 5. So each one of these ticks is actually worth 1 unit. And it's saying that X is greater than 1. So we're going to go to the 1, and greater than means not equals to. And on a graph, if you use a parenthesis, that means all the way up to 1, but not including. And what I like to do at this point is just kind of highlight in with a big arrow saying I'm going in that direction. So how I read this one here is that X is greater than 1, the parenthesis says greater than. Had I put a bracket there, that would have been greater than or equals to, but with the parentheses it's only greater than, and it's going in the direction of the right because it's all the numbers bigger than 1. And how do I test that? Well, let's just take a test point. Let's plug 5 into the equation. So I've got 5 for X. Is 5 greater than 1? True. So I have highlighted them in the right direction. So how do we write this answer in inequality? Well, an inequality is what you already saw the answer written in, X greater than 1. Pretty straightforward in this case. It's every number bigger than 1. Now, interval notation is a little different. It tends to look like a point, and it can be confusing at times, but you have to remember the context you're in. If you see a Cartesian plane and you're plotting points, well, that interval notation really is not interval notation. It's a point that you plot, just like we've been doing already. But if it's asking for an answer that has more than one value, you know, in this case, any number greater than 1 works as an answer, then you know that the interval notation is actually for an interval. And in this case, it goes from 1, and so we always want to start from on the left-hand side, the farthest left it can go. In this case, it doesn't go any farther than 1, and it goes all the way to infinity. What I typically like to do, too, is say that it's going positive infinity. Now, positive infinity is not like all values that are positive. It's saying it's going in the direction that's positive or to the right. Just like when we add on the number line, positive means going to the right. Alright, so now I'm going to put my parentheses or brackets. Now I put a parenthesis around the 1 because it was never equal to, if you look at the original inequality, and I show that on the graph here. But I also put a parenthesis around here because X can never be equal to infinity. Infinity is not a number, it's a concept. The concept is that it goes on forever. It's not a number, so it can never be equal to. So in set builder notation, which is a slightly different way to describe things, you take and you start out with the funky looking bracket that we have on the end there. Kind of looks like a face with a big head and a big chin. And you start out and you say something like this: x, in other words, the variable that we're going to talk about is the variable x, because there may be more than one in any situation. And then we put the line such that x is greater than 1. Now that's all we need to say there. And let me talk about that a little bit. Sometimes when you say x and such that, you list a bunch of numbers beyond that because maybe it's just specific numbers that it will work for. But this is these are all solutions, these are all answers to the question of when is x, what are the values for x that make x greater than 1 true? What makes this true? And the statements down here match that up. So in the one case, inequality, it's already written as that. Interval notation says from 1 to positive infinity. And then here we have set builder that says x such that x is greater than 1. It's just a way of talking in mathematics. So let's take a look at another problem here. Now we have something a little bit more complicated because now x is defined between two numbers. It's between 0 and 4, and it's any number between them with the exception of 4. So I can go start at 0. In this case, you're going to see me put a bracket because note the less than or equals to. 0 is less than or equals to x, which is less than 4. So, and then over on this side I put a parentheses because there is no equals to on this side right here. There's nothing of that sort. So the answers to this problem are anything that's in between there. And we can test this. If we plug the number 1 in for x, then we've got 0 is less than or equals to 1, which is less than 4. Is 0 less than 1? Yes. And is 1 less than 4? Yes. Then we have a true statement. Now if you're looking for the inequality on this one, you may have noticed that you've already got it. 0 less than or equals to x, which is less than 4. And you're done. Now with interval notation, we start from the far left. 0 is the far left. The far right is the number 4 over here. And all we got to do is bracket or parentheses, and it looks just like the graph. If I have a bracket over on this left hand side by the 0, I'm going to have a bracket here because it also, now this says that 0 is included. But I'm going to have a parenthesis here because it goes from 0 to 4, but 4 is not included. But 0 is because there's a bracket around it. Now in set builder notation, it's really just another way of writing what we've done before, so that x is the variable we're going to talk about, such that 0 is less than or equals to 2x, which is less than 4. And then you close that off. The most important one that you need to get comfortable with is interval notation. I'm going to add that in right now. That is an essential part of understanding and dealing with Algebra 2. So really try to focus on that one. And the best way to describe it is it's basically a shortcut way of writing what's already in the graph. It's a shortcut way. I don't have to shade anything in. I don't have to do anything of that sort. So now let's take a look at this next example here. In this one we have a graph. We don't have an interval, we don't have an inequality, we don't have anything other than the graph. But it looks like the graph goes from this point here, which we got to figure out, all the way over to this point here. And so what I'm going to do is see that I've got 1, 2, 3, 4, 5 lines, and this says negative 10 here. So that must mean that these go by 2. So that's negative 2, negative 4, negative 6, negative 8. So it goes from negative 8 all the way to whatever we have here. So we got 2, 4, 6. So the easiest thing to do actually I think might be to do the interval notation first. And we go with the smallest number first, negative 8, comma, all the way to 6, and we just got to decide where a parentheses and bracket goes. Well, according to this, there's a bracket around the negative 8, so it includes negative 8, but there's a parenthesis here, so it says everything all the way up to 6, but not including 6. And we're done with interval notation. So to me, then, it might be good to go back to inequality. And in this case, let's start out with the number on the left, negative 8. Is going to be less than or equals to x, meaning that x can be negative 8, but it can be all the numbers above 8, negative 8. So negative 8 is less than any of those other answers. And then is going to be less than, but not less than or equals to 6. And why is it not less than or equals to 6? Because this bracket is not, or this here is a parenthesis and not a bracket. Now set builder notation, again the guy with the big forehead and the big chin, x such that -8 is less than or equals to x, which is less than 6. Oops. And then the other, his ugly brother, big forehead, chin, and a funky nose, gives us the end of the set builder notation. And again, I'm just going to highlight it one more time. The most important thing in here to understand and get down is the interval notation. Absolutely. Now I will test you on all of these, but once the test is done, the one that we're going to focus on the most is interval notation, but you will see inequalities quite a bit as well. But interval notation is something where, as you get into higher mathematics, it is very helpful. So when you guys go take your calculus class, that will be huge. So let's take a look at another one here. And in this case, I've decided to make one here that's a little funkier so that we can see, well, what happens if we have a graph that's split that's not continuous? Continuous means that it never stops. And so what we have here is really two inequalities with a comma between them. One saying -3 is greater than or equals to x. So I'm going to go over to -3 here for a second. I'm just going to label that for myself. And it's saying that -3 is greater than or equals to x. So x is actually smaller than -3, so it's on this side of it. And since it's greater than or equals to, it's a bracket, and so my answers go off in this direction. Now let's take a look at the second spot. So it says x is greater than 5, but not equal to. So I've got a parenthesis, and it looks like any number bigger than 5. So 6 is greater than 5, 7 is greater than 5. So we're going to go in this general direction over here, and it's a parenthesis because it's not equals to. So what I have now is a graph that really has this non-continuous middle spot. So how do we deal with that inequality? Well, luckily it's already taken care of for us. -3 is greater than or equals to x, comma, x is greater than 5. Now interval notation is really going to be in two sets here, because I've got to deal with this part over here and this part over here separately. So let's deal with this one first. And what's the farthest left? It's infinity. But what direction is the infinity going? It's the negative direction. So I'm going to put it negative infinity, comma, all the way to -3. And now that's a question of parentheses and brackets. Well, it's bracket around the -3 because it was greater than or equals to -3. -3, I'm sorry, is greater than or equals to x. But it's always a parenthesis around an infinity sign because infinity is not a number, it's a concept. Now we'll put a comma there because we have another part of the interval notation. So now we're going to start with the smallest number on this side over here, which is 5. 5, and then all the way to infinity again, but positive infinity this time, so going to the right. Now I put a parenthesis around there because 5 is not included and infinity is not included, so I put a parenthesis there. So there's your interval notation. Now in set builder, it's really, I mean, if you take a look, if you haven't noticed it yet, it's just like writing an inequality. X such that negative infinity, oops, my apologies. So it's set builder notation. It's really similar to an inequality, if you haven't noticed already. So we have x such that -3 is greater than x, comma, x is greater than 5. So again, I really want to harp on this graph. No, I kept drawing a graph here to help us out, to make things make sense for you, to give you a visual aid. You need to be writing graphs down, or you're just not going to get these problems right. Calculating interval notation is extremely important, and you need to be able to interpret between the interval and the inequality notation. Set builder we'll see here and there, but it is not really the end-all be-all of this. It's just something that you need to be aware of. It does exist and it is out there. This concludes our lecture on lesson 1-1. It's the light blue sheets. This is part 3 being finished.